All right, hello Mathcounts friends. So this is part 2 of the state sprint round for 2026, and I'm joined once again by my son Kenton, who took the test. He's going to help me out with some of the problems. We'll take turns kind of explaining the problems. So let's go ahead and jump right in. This is number 11. I'm going to be doing numbers 11 through 20 in this video, and then we'll do one final video with the really hard ones, 21 through 30. So this says, what is the remainder when 23 to the 23 power is divided by 5? Okay, so when you have this kind of a problem, basically you just look for a pattern in the last digit. That works well if you're looking at the remainder when divided by 10. But actually, it will also work with the remainder divided by 5. But if it's, you just have to worry about, like 7 has the same remainder as 2, for example. But if it was a different number here that was not divisible by 10, what you need to do is find the last digit mod that number at each power. So let me give you an example. We'll explain it. So if you take 3 to the 0 power, that's 1, right? And then if you take 3 to the first power, that's 3. And again, I'm just looking at the last digit. And then 3 to the second power, what I'm going to do is I'm going to say, okay, that's 9, but we're looking at the remainder when divided by 5, so I'm going to mod it by 5. 9 mod 5 is going to be 4. And then if I multiply that, instead of actually doing 3 cubed is 27, I'm just going to take 4 and multiply that by 3, which gives me 12, and then 12 mod 5 is 2. And then I can do 2 times 3 is 6. If I mod 6 by, so instead of 3 cubed here, this is going to be 4 times 3. And this one's going to be 2 times 3. 2 times 3 is 6. And if I mod, I get to 1. And what you'll see if you keep going is that, you're going to do 1 times 3. But we already did that here. And you're going to get 3 again. So what's going to happen is you're going to continue on with this pattern. The pattern has a length of 4. And so it's going to repeat this pattern every 4 exponents. It's going to repeat the pattern. So when you get up to the 20, well, if you went all the way to the 23rd one, that should be this last one here, I believe, because like we started at 0, and if you did 6 of these, 1, 2, 3, 4, 5, 6, that would be from 0 up to 23. So this last one should be the answer. So the final answer here is 2. All right, Kenton, you want to take it away?
Sure. Okay, so now we've got if x plus x over 2 plus x over 2 squared plus x over 2 cubed is equal to 30, then what is the value of x? So you can combine all the terms here to get x times 15 times 1 plus 1 half plus 1 fourth plus 1 eighth is equal to 30. And then 1 plus a half plus a fourth plus an eighth is 15 over 8. That's pretty easy to see just because of, a half plus a fourth plus an eighth is 7 eighths, and then you add 1, that gets you 15 eighths. And now you can multiply both sides by 8 over 15, and then that will give you what x is equal to. So you cancel the 15 with the 30, that gets you 2 times 8, 16. And that should be the final answer.
Okay, that's the final answer, 16. All right, number 13 here. Using the equation 6 equals 2m plus b, all ordered pairs MB are plotted in the MB plane forming a line. What is the area of the triangle formed by this line? The line M equals 0 and the line B equals 0. Okay, so the line M equals 0 is just the, the line M equals 0 is the B axis. And the line M equals 0 is the B axis. The line M equals 0 is the B axis, and the line B equals 0 is the M axis. So those are two of the lines. And the other line is given by this equation. It's a little interesting. I think they're trying to confuse you because usually you have mx plus b equal y, but here you've got an M axis and a B axis rather than an X and a Y axis, which is what you're used to. So you might get confused by all of that. But don't despair. Well, one way to do it is to just plug in M equals 0 into this equation. And if you do that, you get 6 is equal to B. So when M equals 0, let me do this in a different color. When m equals 0, you're going to have 6 is equal to b, and that's going to be up here at 6. And then you can plug in b equals 0 into the same equation. So maybe we'll do that in a different color. So b equals 0, you're going to have 6 equals 2m. And then that's going to be m equal 3. So then m is going to be 3 here. And then you know that the line containing those 2 points, you know it's a linear equation here. This is a linear equation. And so it's going to be a line that connects those, basically. Oh, that was a terrible line. I'll use the line tool. It's a little better. Okay. So then you've got a triangle, and we need to find the area of that triangle. Right? So that's in here. And it's got a base of 3 and a height of 6. So it's going to be half of 3 times 6, which is just 3 squared, which is 9. So 9 is going to be our final answer on this one. All right. Kenton, number 14.
Okay, so this one says, for how many positive integers n is there no positive integer strictly between 1/2 of n and 3/5 of n? So a nice way to deal with this problem is to put an upper bound on n. So the way you can do this is if 3/5 of n minus 1/2 of n is greater than 1, then you already know that there's going to be at least one positive integer strictly between 1/2 n and 3/5 n. So that means we can't count any of those ones. And so we have to count the ones where 3/5 of n minus 1/2 of n is less than or equal to 1. And so you can figure out pretty quickly that n is less than 10. And so if n is less than 10, should be less.
Oh, I put the wrong. Okay, let me fix that. Sorry, Kenton, it should be less than.
Less than or equal to.
I thought we were talking about the case where it's greater.
Yeah.
So the case where it's greater, it's not possible.
Yeah.
So if n is greater than 10, then it's not possible. Should we just keep it like that?
Yeah, okay. So if n is greater than 10, then it's not possible. So now we need to figure out from 1 to 10 how many of those integers have no positive integers strictly between 1/2 n and 3/5 of n. So we can first look at the even numbers, and if you've got an even number, then you know 1/2 of n has to be an integer. And you already know that 3/5 of n minus 1/2 of n is less than or equal to 1, which means there can't be any positive integers strictly between 1/2 of n and 3/5 of n. So that's already 2, 4, 6, 8, and 10, which is 5 numbers. And if you look at the small odd numbers, you've got 1. That one obviously has no positive integer strictly between 1/2 n and 3/5 n, because it's 1/2 and 3/5. And then you go to 3, it's got 3/2 and 9/5. And you can tell pretty easily that those two numbers are 1.5 and 1.8, and there's no integer between them. And then if you go to 5, you already know 3/5 of n is 3, and you know 3/5 of n minus 1/2 of n is less than 1, so that means there's no positive integer strictly between them. And then you go to 7, and when you check 7, you find out that you've got 3.5 and you've got 4.2, and you know there's an integer between those two, so that's not one that you want to count. And then you go to 9, and you can do the same thing. You've got 4.5 and 5.6, and there's an integer in between there, or 5.4, I think. And so now you know that there's 5 even numbers and 3 odd numbers, and that gives you a total of 8, which is your final answer.
All right. Great job. Okay, let's go on to number 15. So this one says, Andrew sells Mia a rectangular plot of land with an area of 60 square feet and all sides measuring a whole number of feet. Mia extends the width of the plot by 4 feet while shortening the length by 2 feet. What is the greatest possible area of Mia's new plot of land? Okay, so there's a width times a length is equal to 60. And now, after Mia's modification, the width is now width plus 4, right? And the length is now length minus 2. And we want this thing to be as big as possible. Okay, so we can multiply this out. This is going to be width times length plus 4 times the length minus, yeah, maybe I should just, I don't know, my L is not great, but 4 times the length minus 2 times the width minus 8. And this is a constant, and this is a constant. Because when whatever the width and length was, you know, that's what it was. And so, well, is that right? Let's see. Yeah, because it's 60, right? The width times the length is 60. And so when I'm choosing the length and the width, if I make the length bigger, that's going to make the width smaller. And that's really going to help increase my area after the modifications because 4 times the length is added to the area. And it's also making the amount that's subtracted smaller. So I just want the length to be as big as possible. But I have to have a constraint that they have to be integers. So if it wasn't for that, I'd just make the length, you know, as big as I could possibly make it. You know, it would go to infinity. But they have to be integers. So we'll make the length 60. So we'll say the length is equal to 60 and the width is equal to 1. That's the best we can do. And then they say, what is the greatest possible area? Well, that will be the width plus 4, that'll be 5, times the length minus 2, that'll be 58. And then 5 times 58, let's see, that'll be 250 plus 40, is that 290? Yeah, 290. So that's the answer to this one. All right. Another way to do it is just to say, okay, you might intuitively say, oh, look, you're making the width bigger. And so, you know, you can think about that rectangle. When you make that width bigger, it's going to add, it's going to multiply the area by 5, basically. If you make the width only 1, it'll multiply by 5. If you make the width bigger than 1, it'll multiply by something smaller. And so, yeah, you just want to make that width as small as possible. Okay, let's go ahead and go on to number 16.
Okay, this one says we've got an isosceles triangle which has two side lengths of 20 and 26. What is the sum of the squares of the possible lengths of the altitude to the side of the triangle whose length is different from those of the other two sides? So we know it's an isosceles triangle, which means two of the side lengths are the same, but we don't know if there are two 20s or if there are two 26s. So we have to account for both of these cases. So there's the case where you've got a 26 and a 26, there are two 26s, and there's the case where you've got two 20s. And so for both of these, you can take half of the base, and that forms a right triangle with the length of the other side. And from here, you can use the Pythagorean theorem to find the square of the altitude. And so that's not too bad. We just do 26 squared minus 10 squared. It's going to give us 576, which is useful if you remember your squares. And then you can do 20 squared minus 13 squared. That's going to give you 231, I think. Yeah, 231. And then you can add those two together because remember we're looking for the sum of the squares. And that gets you 807, which is your final answer.
Okay, excellent. All right, let's take a look at the next one. So this is number 17. And this one says, Fry and Amy are playing ping pong. They take turns serving, starting with Fry. Okay, so you got Fry serving first. When Fry serves, there's a 50% chance he will score a point and a 50% chance Amy will score a point. Okay, so 1/2 for Fry and 1/2 for Amy. And when Amy serves, there's a 70% chance that she will score. Okay, so when Amy serves, 70% chance she will score and a 30% chance Fry will score. So there's a 30%, we'll put 3/10 for Fry and 7/10 for Amy. This is a tough one. They keep playing until one of them scores 4 points. What is the probability that Fry serves at most 3 times? Express your answer as a common fraction. Okay, so you're going to have Fry, then Amy, then Fry, then Amy, then Fry, then Amy, and then Fry, potentially. Now, this is actually the longest you can go, is 7 points. Because once somebody scores 4 points, the game's over. And somebody's going to have to score 4 points by the time you get to 7. And so it says, what is the probability that Fry serves at most 3 times? Well, that means anything that any game that ends anywhere up to here is going to satisfy that. So basically, the way to think of it is complementary probability. You find the probability that it's a 3-3 tie after 6 points, and then you do 1 minus that probability. Because in order for you to get to this point here, it's got to be a 3-3 tie after the fa, after the Fry, Amy, Fry, Amy, Fry, Amy. So basically, so just to summarize that, it's 1 minus the probability of a 3-3 tie. So we got to figure out the probability that you're going to get a 3-3 tie after these 6 points. So this is kind of casework. You got to break it down into a few cases. What you can think about is how many of Amy's serves does Fry win? Okay, so you could say Fry wins 0 of Amy's serves, 1 of Amy's serves, 2 of Amy's serves, or 3 of Amy's serves. Let's take those 4 cases. So the first case is that Fry wins 0 of Amy's serves. So the probability of that is going to be 7/10. Let's see, 7/10 cubed, right? Because Amy's got to win all 3 of those. So this one, and this one. And then you got to multiply it by 1/2 cubed, because Amy, let's see, Fry will have to win all of the ones. Or no, we said Fry, what did we say? Fry won 0 of the ones that Amy served. So that means Amy won them all. And then that means Fry has to win all of the ones that he served. Regardless of who wins those ones, it's always going to be a half. So all of these, if I fill this in, these are all going to have 1/2 cubed for the probability of winning, of who wins on, 1/2 for who wins on Fry's serves. This is supposed to be a 3. Okay. And then you also have to consider the number of ways, the number of combinations. So for example, within Amy's serves, if some of them are won by Fry and some of them are won by Amy, there's different, it could be Fry, Amy, Fry, or Amy, Fry, Fry, or Fry, Fry, Amy, if there's 2 Frys and 1 Amy. So that means you have to do some combinations, like you have to do 3 choose 0. So the ones that Amy serves, Fry is going to win 0 of those. How many ways are there to choose 0 of those 3 for Fry to win? And then 3 choose 3. How many ways are there to choose 3 of the ones that Fry serves for him to win? All right, so that is going to give us some value, and then we're going to fill in all 4 of these rows. So here, these are Fry's serves. For Amy's serves, if Fry wins 1 of them, that's going to be 3/10 times 49 hundredths. I'm just going to write it over 10 to the 3rd. So I'm going to say 3 times 7 squared over 10 cubed, right? Or over 1,000, I guess. I'll just write 1,000. And then for the case where Fry wins twice, it's going to be 3 squared times 7 over 1,000. And then the case where Fry wins 3 times on Amy's serve, it's going to be 3 cubed over 1,000. And then here we're going to have 3 choose 1, 3 choose 2, 3 choose 2, 3 choose 1, 3 choose 3, and 3 choose 0, because Fry's going to win. Well, we're considering the number of ways that Fry can choose 0 of Amy's serves to win, 1 of Amy's serves to win, 2 of Amy's serves to win, 3 of Amy's serves to win, and then 3 of his own serves, 2 of his own serves, 1 of his own serve, and 0 of his own serve. So we got to multiply this all out, multiply this out, multiply this all out, multiply this all out. We'll get 4 answers. We'll add those 4 together, and that will give us the probability of a 3-3 tie. Then we'll do 1 minus that. Okay, so let's make a little bit of room so that we can do that whole calculation here. So I'm going to clear this out. I don't think we need this anymore. Whoops, that was a little aggressive. Okay. All right, so let's take a look here. Maybe I'll grab a different color while we're at it. Okay, so we're going to have 7 cubed. That's going to be 343. And I'm just going to factor out a 1/8. I'm going to actually factor out 8 over 1,000 because these all have 8 over 1,000. So we'll do 8 over...
1 over 8.
Oh, no, it's 1 over 8,000. Thank you, Kenton. So, yeah, this whole thing I'm going to multiply at the end by 1 over 8,000. 8,000. 1 over 8,000. Okay. So we've got 343 times 1 times 1. So this is a 1, this is a 1, this is a 343, this is a 1. And then here we've got, let's see, 49 times 3 will be 147. But then I have to multiply by 9 because this is 3 and this is 3. So 147 times 9, that's going to give me 1323. 1323. And then the next one down, I've got 9 times 7, which will be 63, and then I have to multiply by 3 times 3, which is 9. So 63 times 9, let's see, that gives me 567. Yeah, I also, well, yeah, it's kind of a pain to have to calculate all that stuff. And then this last one, these are both 1, and this is 1, and this is 3 cubed, so this is 27. So we have this sum times 1 over 8,000, and then we have to do 1 minus that. Okay, so what that's really going to be is 8,000. If I do 1 minus that, it's going to be 8,000 minus that whole sum divided by 8,000. And I'm going to just bring up Python here. We're going to do 8,000 minus this sum, which was 343 plus 1323 plus 567 plus 27. And I know on the Sprint you can't do this, but I'm cheating. So we've got 5740 divided by 8,000 now. 5740. So this is going to be 5740 divided by 8,000. Now you can obviously cancel a 10. You got to put this as a common fraction, and then you can cancel 2 again. So this is going to be 287 divided by 400. And 400 just has prime factors of 2 and 5, which are not, 287 is not divisible by either one of those. So this is going to be our final answer in simplified form, 287 over 400. That was a tough one. I know, Kenton, you skipped this one because you could tell that was going to be a time sink during the test, so that was a smart thing. It's good to watch out for those problems that have a lot of casework or that are just going to be tough to get done. All right, let's take a look at this one.
Okay, so this one says if 36 to the x plus 1 is equal to 6 to the 8th, then what is the value of x? So basically, 36 is equal to 6 squared. So that means that 6 to the 8th is equal to 36 to the 4th. And you know that because if you take 6 squared to the 4th, it's equal to 6 to the 2 times 4, which is 8. So we basically got 2, just do x plus, yeah, you can do 2 times x plus 1 is equal to 8, or you can just do x plus 1 equals 4. And then from there you've just got 3 for your final value of x.
Okay, x is 3. Very good. All right, we've got 2 more problems to go, so let's go ahead and take a look at number 19. This one is about a regular hexagon. So I'll get my line tool and we'll see how this goes here. So we've got a regular hexagon A, B, C, D, E, F. Let's go ahead and draw something that looks hexagonal if we can. So something like this. It's probably not perfectly regular, but oh well. Pretend. I'd like to make it a little better than that. We'll pretend it's a perfect hexagon. All right, and it says the side length is 2. Okay, so the side length is 2. Every side length is 2, right? And it says let P, Q, and R be the midpoints of AB. So let's say this is AB here. That's P is going to be midpoint here, and then AB, CD, and EF. So those are those points, P, Q, and R. And then it says what percent of the area of the hexagon is the area of PQR? Okay, so we got PQR is going to be this triangle here. Okay. Now, one thing you can do, I'm going to grab another color, I think. One thing you can do is you can draw the lines that connect opposite corners of this hexagon. And if you start drawing those lines, what you find is that you're starting to make smaller triangles in here. And all these smaller triangles, you can draw also these lines here, and these lines here, this other triangle basically. And when you do that, you'll find that you've got a bunch of triangles. And all the triangles have side length 1. Okay, so you can convince yourself of that. When you split this in half, you're going to have 1 and 1. And then these are all at a 60-degree angle, so they're all going to be equilateral triangles. And all these things are 1. So all these triangles are going to have the same area. So if we can figure out the number of triangles inside of our PQR triangle, a number of little triangles inside there, and compare it to the number of little triangles in the whole thing, then we've got our fraction. So inside this PQR, this is P, Q, and R. Inside that triangle, we've got a row of 1, a row of 3, and a row of 5. 1 plus 3 plus 5 is 9, so we've got 9 little triangles inside that big triangle there. And then how many triangles are in the whole hexagon? Well, there's many different ways to do that. You could count them all, but I think it's kind of useful to break the hexagon into 6 smaller triangles like this one. And this medium-sized triangle, I guess I'll call it, because we got even smaller triangles, but this medium-sized triangle has 4 of the small triangles, and there are 6 of those medium-sized triangles to make the hexagon. So the total number of triangles is going to be 4 times 6. And so our answer is going to be 9 over 24. And I guess we got to simplify that, so that'll be 3 over 8.
It's a percent.
Oh, well, they want it as a percent, and they want it rounded to the nearest whole percent. So 3/8 is, as a decimal, is 0.375. As a percent is 37.5. And when you round 37.5 to the nearest whole number, you get 38. So our answer here is going to be 38%. Okay, let's take a look at number 10. Or 20, I'm sorry, 20.
Okay, so this one says, how many distinct arrangements of the letters in the word probability contain the sum arrangement PRO, whose letters must appear consecutively and in that order anywhere in the arrangement? So the way to do this one is to call PRO a single letter. And now sometimes you can't do that, but right now we can, and there's 2 reasons. One is because the letters must appear consecutively and in that order, which means that they have to be together and they have to be in that order. And the other is that there aren't any extra O's or R's or P's in the rest of the word. And so now you can call that one letter, and now we've got the pro, which is like a letter that we made, and then, so that's 1. And then we can count up the rest of the letters, 2, 3, 4, 5, 6, 7, 8, 9. And so now you've got 9 factorial. But that's not your final answer because you have to divide by the repeat letters. There's 2 B's, so you have to divide by 2. 2 factorial, I guess. And then there's also 2 I's, so you have to divide by another 2 factorial. And from here you can calculate that out. I think the easiest way to do this is to break it up into 9 times 8 factorial. If you've got your factorials memorized, then you can know that 8 factorial is 4320. And then you can divide 40320. It should be, yeah, 40320. And then you divide that 40320 by 4, And now you've got 10080. And then you multiply that by 9, and you get 90720, which is your final answer.
Okay, that's a good reason to memorize your factorials up to 8 factorial. Or maybe even up to 9 factorial. That would help in this problem. Okay, well that's the last one from the 11 through 20. So we're going to see you guys soon in the part 3. So stay tuned for that one.